this is question number 2, based on fundamental and what? Derived quantity. The one we did earlier, it is heat capacity, and it is a what? Derived quantity, because we have mass there, and mass is from what? Fundamental what? Quantity. Now let's see this one too. This one, specific heat capacity, is also from what? Derived quantity. And what are we asked to do? What is the correct SI unit of specific heat capacity? This question is not asking about heat capacity, but what? Specific heat capacity, which is ordinary C. The other one is MC. This one is what? Ordinary C. The same what? The same for equation, it implies this as well. What is that? Q, since it is heat that we are talking about, equals to what? MC, change in what? Change in theta. Now, what do we make the subject of the formula here? Since it is what? Specific heat capacity, it is only C. We make the subject of the formula. And what would that be? Divide through by M and what? Change in theta. M, change in theta. We will be left with only what? C. And this one too, it will be M, change in theta. Whatever that happens to this side must also happen to this. Now, M settles what? M. Theta, change in theta, settles change in theta. We are left with what? We are left with Q equals to M, change in what? Theta equals to what? C. Are we together? Now check. This, is it a derived quantity or fundamental quantity? It's also a what? Derived quantity. As a result of what are we having here? Mass. Is a fundamental quantity. Coupled with what? Temperature is also a fundamental quantity. To form a what? This particular specific heat capacity. That is why we classify specific heat capacity as a what? Derived what? Quantity. Are we together? Now, what are we asked to? We are asked to SI unit, not the formulas. The SI unit will be, already I have told you that Q, it is heat, which is measured in what? Joule. We can rewrite this back like C, Q, all upon M, changing what? Theta. Are we? C will now be, what is our Q? Q is what? Joule. This divide will change to per. Mass, what is the standard SI unit? It is kilogram. Then mass and temperature, what is sign that is between them? Is it plus, minus, or times? It is what? Times. So therefore, it is times. Temperature, what is the standard SI unit? It is K. Then we have it to be what? Joule per what? Kilogram Kelvin. Are we? Joule per kilogram Kelvin. Now let's see the options here. 1. Joule per kilogram Kelvin. B. Joule per Kelvin. C. Joule seconds. Joule per seconds. The one would that be? Is it A? Is it B? Is it C? Now the correct option, see, this one is it is starting with this. The correct answer will be what? Will be A. That is that under that. Are we together? This question is also prepared from what? Sub-academic what? Class. This is question number 3. The unit of what? That means the SI unit of PD. When we say PD in physics, we mean potential difference. It's also the same thing as voltage. Either you call it potential difference or you call it what? Voltage. Is what? From the following below. That means from the following options below. We have Newton meter per coulomb. We have Newton per coulomb. We have volts per what? Per meter. We have ordinary volts. The options are these. Now, what do we do? Now, from these options we are given, we have A to be this, we have B to be this, which is this and this. We have C to be ordinary this. Are we together? Now, note that I'm suggesting the answer should be A. Why? Are we together? Now, this can be. I'll tell you the reason why. This can be. The answer should be this and this. How? Note that anything voltage, the SI unit is what? Volts. But in this option, do we have only volts? Volt is what? Number 4, Roman figure 4. We didn't have anything there. The only way we have volt, it is this one, option A. And we still have this. Why did they pick this? Assuming it is the only volt that is there, we can pick option A. But we still have, coupled up with this number 1. How do they get this number 1? Now, all you need to know is that to get this number 1, we have a topic. We call it what? Feed in physics. And we have what we know as, under that feed, we have what we know as what? Electric field intensity. Electric what? field intensity, which is under Coulomb's law of electricity in physics, where we will be talking about E equals to F over what? Over Q. Are we together? This is electric field intensity. This is force. This is what? Charge. Make, all you need to do now, make F the subject of the formula. Are we? We want to prove this one. Make F the what? The subject of the formula. What would that be? What I mean, I want to make F the subject of the formula. It will be F times 1. F equals to EQ. Are we together? Note that we have, this is option 1. Note that we have what we know as work done. Normal work done. Which is force times what? Force times distance. Isn't it? Now, force times distance. Wherever I'm seeing what? Wherever I'm seeing F, I will be putting in what? I will be putting in EQ. Right? Because I'm seeing F here. And F is EQ. Wherever I'm seeing force, I will be putting EQ. That means we have W to be what? EQ what? D. Are we together? And note that anywhere you see ED, not EQD. Anywhere you see, you can rearrange this. W equals to what? EDQ. Anywhere you see ED, it is known as potential difference. That means W will be what now? W will be what? VQ. That is another formula for calculating work done under this something. Under this electric field intensity. This is a formula for calculating work done. We are still coming on that. Now, what do we need? Now, we said, I told you that V is what? V is what? ED. V is what? E what? ED. Note that this E, it is from there, right? And that one, the SI unit for this one, where is that? Sorry for that. I hope you have taken this one. You know the SI unit for F is what? Newton per. What is for Q? In this particular one, we don't use joule. Each topic depends on what the SI unit for Q is going to be. This one will be C, coulombs. We use coulombs. Whereas we have it to be Newton per what? Per coulombs for E. And note, I told you that V equals to ED. So wherever, it is SI unit we have to calculate. Wherever I'm seeing E, what will be the SI unit? Newton per coulombs times is what is joining them. What is our D? D, the SI unit for D is what? Meter. Now, Newton times meter will give us Newton meter. Per what? Per coulombs. Are we together? That is how we get Newton meter per coulomb for V. That is another SI unit. Or volt. That is why this option is what? Is correct. Is either volt or what? Newton meter per coulomb. And I have told you how to get this. All you need to do is just cram this formula. V equals to ED. And I have told you how to prove that. Are we together? Which is Newton meter per coulomb. The right option here is what? Option A. Are we together? Now, this is another something. I will give you this as an assignment. Which of these, before we go to the JAMB questions, this is also prepared from the subclass. Which of these is a correct unit of electric field intensity? Which? Is it I? Is it 1? Is it Newton per coulombs? I've explained what an electric field intensity is, which is E equals to F all upon Q, right? And I've still told you that we can still have it to be E equals to what? Equals to VED. We can still say what? Divide both sides by D. By D. This will now be E equals to V all upon D. This is another formula. So use these two formula. This is electric field intensity, force and charge. This is also voltage, potential difference and distance. Use these two formula to find the correct answer here. Is it 1 and 2? Are we together? Is it ordinary 2? Are we together? And is it what? C, is it 4? And D, sorry, is it what? Is it 1, 3, and what? And 1. What will be the correct answer there? Use this one and you'll get the correct what? Answer there. Let's quickly go to the what? The JAMB practice question.